All right. Good afternoon, everyone, and welcome to the webinar Virtualization run by Adfinis in cooperation with Red Hat. Ales Zelenik, our senior system engineer at Adfinis, will start with a presentation. Then he will display a live demo. And lastly, he can answer any of your questions. If you have any questions during the presentations, feel free to use the Q&A button in Zoom. We will try to answer during or in the Q&A session. Ales, I'll give the mic to you.
Great, thanks, Max. Hello and welcome, everyone. So we only have 1 hour. I'll try to keep it brief and have the presentation through in that time and also a short demo of the features. It's challenging, but if you have any specific questions, feel free to ask out. Okay, so first, this is a demo. This is a presentation about OpenShift Virtualization. Now I will first go through what OpenShift Virtualization is. Just a couple of slides for the start, and then we can also deviate into some more practical discussions. OpenShift Virtualization is a platform for running virtual machines and containers together in one consistent system. So it gives you tools to manage virtual machines in a cloud-native way. If you have already used containerization solutions like Kubernetes or OpenShift, then all this process would be very familiar to you how to apply it to running and performing administrative tasks on virtual machines. It's based on upstream project called KubeVirt, and which is also using and leveraging below its solution as a virtualization kernel virtual machine, which is a Linux integrated tool for providing type 1 hypervisors. So this tool has been part of the mainstream kernel releases for almost 20 years now. It's mature. It has all the features that you would expect from any other virtualization tool. It is certified to run Linux and Windows workloads and can do that at scale. And it's already proven in many very big and critical environments. What OpenShift does to that is an additional tool that exposes that powerful solution to the OpenShift container platform. So if you look here, you will see that containers and virtual machines are treated as first-class citizens. In that case, you can mix and match workloads that are dependent on multiple components. So you can have some of them running in containers, some in virtual machines. They can communicate between each other. The high availability guarantees that the platform provides for containers is also similarly applicable to virtual machines. And if you have familiarity with OpenShift already, virtualization is just another operator which exposes all that functionality, and it integrates seamlessly with all the other tools and solutions that you already have in place. If you are using virtual machines and you have a Red Hat OpenShift container platform license or a license for Kubernetes engine or higher, then you also have entitlement for running Red Hat Enterprise Linux as a guest included. This means that if you start moving virtual machines that are already using Red Hat Enterprise Linux from your existing platform to OpenShift, you don't need to have a separate license entitlement for them. Also, Microsoft guests are supported and certified through Microsoft certification program for that platform. So you will not lose any kind of, let's say, guarantees that Microsoft will provide to you regarding the workload support. So what do you expect from virtualization tool? Of course, creating, managing VMs, which is something that can be very simple. You can already have a solution based on like a single hypervisor and just run machines there. You can have a whole data center deployed with, let's say, vSphere that is able to utilize multiple machines, multiple clusters across data centers. All those tools are implemented in a similar way through the OpenShift Virtualization platform. Things that other platforms cannot do is to run pods and VMs alongside each other. This is a very powerful tool that allows you to gradually migrate VMs to containers, for example. And if in case of using some, let's say, legacy tool that is only deployable on a VM, it allows you to bring that workload in the same system, which can leverage all the additional tools that Kubernetes and OpenShift provides. For example, secrets management, configuration maps can be used. Automated service discovery, ingresses, and one of the features that is also worth mentioning here is it abstracts away your storage configuration. This is all based on a typical, on a standard persistent volume and persistent volume claim concept, and allows you to do the backups with them, snapshots, and all of that. Of course, integrates and is and it's managed through the CSI drivers, which support a myriad of different storage providers. Of course, so you can also do live migration between nodes and manage network interfaces and attach additional storage drives. Depending on the operating system, that can be done live, it can be done, or it can be done with a short downtime. So why would you use OpenShift virtualization? Is because you want to manage VMs and containers in the same control plane, which is a very very powerful advantage that you can apply to your organization because it removes one way of managing your workloads from the required abilities that you need to be able to support. OpenShift abstracts away the platform that it's using below. So the hardware, it can be running on a existing hypervisor. It can run on bare metal. It can run on a cloud. For your workloads and the way you manage them, this has zero difference. So it makes it a lot easier also for you to change or mix the workloads between different platforms. I will also talk about some subscription models later, depending on what version of variant of OpenShift you choose, and with some, let's say, changes lately with subscription models from other vendors. Maybe this is also one of the drivers that would weigh the scale into the favor of using OpenShift. Of course, no presentation today can be done without mentioning AI, because VMs can expose hardware directly inside of its operating system. You can use GPUs to expose them inside of your workload if that is for purposes of AI, or you have some high performance computing requirements, all of that applies, and you have pretty much zero overhead of running virtualized instead of just on bare metal. Now I'll deviate a little from the presentation. Now my thinking here is that there are two types of people or organizations who are looking at adopting OpenShift virtualizations. So you have organizations that have no experience with containers. They still run everything on virtual machines. They have used hypervisor technology for all their workloads. Here I'm talking about, let's say, Hyper-V, vSphere, Proxmox, even OpenStack or Nutanix. And you're looking to support in the future workloads that are containerized. Why would you want to do that? You probably onboard new applications all the time. If you have some internal development, you can distribute those as container images. Maybe now you just have a VM that is running some subset of containerization, like, I don't know, you just run a Docker Compose and have containers in that, but everything is still on VMs. With OpenShift container platform, you can then migrate all those workloads to native way of managing them using concepts that are much more natural and applicable to those types of workloads. So for that purpose, you can do that very gradually. You can start with OpenShift Virtualization Engine, which is a new product that has been released in last year. What it allows you to do is execute your VMs on OpenShift Virtualization Platform. It does not allow you to run additional containers for your workloads, but after you are able to migrate everything from, let's say, your legacy hypervisor platform to OpenShift Virtualization, it would require from you to adopt, let's say, a cloud native way of managing those workloads. And after you are comfortable with that concept, and you have already migrated everything to OpenShift Virtualization, the next stepping stone is to start running containers. You have already established all the patterns, and you have the knowledge that is already applicable from the actual migration to OpenShift Virtualization of the VMs. So you can then, because you can mix containers and VMs together, you can do the migration then gradually. You decide you just want to instead of having a VM for some workload, use a container because it's still all connected in the same system. It doesn't really affect any kind of interoperability, or it doesn't force you to do the whole project or all the virtual machines that you use for some solution to change them immediately and in one big move. Simplest, or let's say cheapest way to start with, you can start with a very simple solution such as a free node cluster. You would need 3 dedicated hardware nodes where you can run infrastructure and your workloads together on the same hardware. And in the future, then you can expand by just adding additional worker nodes. What is also very powerful concept here is that you only pay for subscriptions for your workloads. So any kind of control plane or infrastructure workloads that come and are part of OpenShift, you don't need to have a subscription for them. You only need to subscribe your hardware nodes or your CPU entitlements for the compute that is actually used for hosting your workloads. So this is one aspect. And the second aspect is you already have containerization adopted in your organization. You already know what OpenShift is, how it works. So for you, I can just say this is just another operator that you install. It's included in all versions of OpenShift, also all subscriptions. You already have knowledge how to manage your existing containerized workloads using, let's say, GitOps patterns and have software development lifecycles and CI/CD pipelines already adapted to that solution. So it's as easy as adding an operator and with a compatible storage layer and enough subscription entitlements, you can start running virtualized workloads today. Okay, so when you either way you start, you will always end up with a full-fledged OpenShift platform that gives you exactly same capabilities, and having that capability of running containers and VMs on the same platform as mentioned is very powerful. I'll give you a couple of seconds if you have any questions. Otherwise, I'll continue. No open questions. Okay. So, okay, this is basically what I just have described. You will always have, you may have workloads that will never be containerizable, and you can then just continue running them on the existing platform. And of course, allows you a gradual migration. And you may have some workloads that require some have higher requirements on isolation. So you may need to continue running them in VMs. All of that is supported, and in the long term is a completely viable and acceptable solution. And this will not change with running it on OpenShift. So now how that looks like in the cluster architecture. All those components that you see here in gray, apart from KVM and virtual machines, are components that are part of standard OpenShift. The addition that OpenShift virtualization operator adds is support for KVM and running virtual machines on top of that KVM. For its storage and for its state, it depends on the persistent storage interface. So that interface can be implemented by many different providers. I'll get to the list later. And if they provide read, write, many type of access, so meaning that one volume can be mounted by multiple nodes at the same time, it will allow you to live migrate VMs between the nodes in case you have, let's say, planned maintenance. Of course, in the case of unplanned maintenance, in other words, crash of a node for whatever reason, the OpenShift control plane would take care of moving the virtual machine to another node and restarting it. Okay, so there are 4 different subscription options for Red Hat OpenShift. All of them include virtualization. The new one that is applicable to the use case that I have described as first, you have no prior experience with containerization, is Red Hat OpenShift Virtualization Engine. It can only be deployed on bare metal. What is also different in this version is that it does not include subscriptions for Red Hat Enterprise Linux. So if you have that requirement, you would still need to have that covered, either by as a separate subscription or by upgrading to one of those options. Typically, what we see in practice is people are running Red Hat OpenShift Container Platform, which allows management of the full software development lifecycle. It's meant for let's say single deployments where you don't have like multiple clusters, more than 2 or 3. If you have this kind of requirement, then usually you go with the Platform Plus, which allows you to use a centralized control plane to managing all the clusters from one point of view and control. Okay, so for people who are more familiar with the vSphere, the concepts that are used by OpenShift virtualizations are translatable as such. So the data store is replaced by persistent volume and persistent volume claim. Resource scheduling is already part of the typical Kubernetes or OpenShift deployment, so it allows you scheduling and very fine-grained control of how and where and when pods or VMs are being assigned to. Networking part, OpenShift uses OVN Kubernetes by default. This is a layer that allows communication between all the workloads in a transparent way, and of course, has control to limit who can speak to whom. And that is already being applied also to the VMs. You can also integrate with third-party container network interfaces. For example, you're using Cisco ACI. You can even integrate with NSX if you have that. But the functionality that, for example, NSX provides you, which I don't believe is a default option in vSphere, it's an additional component, is already provided by default OVN Kubernetes. So it gives you an overlay and visibility and control over it. Storage, like I'll show you at next slide, what vendors are supported as first class. That doesn't mean that other vendors are not, or there are no solutions for them. A lot of let's say hypervisors rely on a robust and high performance storage. There is no exception here. You can also use a hyperconverged storage, meaning that you have your nodes that are hosting your workloads are also nodes that are taking care of the storage abstraction, all the replications and migrations and snapshotting and all the typical solutions that you would need to run stateful workloads. If we go back here, Red Hat OpenShift Platform Plus gives you a support for ODF, which is OpenShift Data Foundation. It's a solution based on Ceph, which provides exactly that. It provides the hyperconverged storage. Okay, so for metrics and monitoring, OpenShift has a first-class support through Prometheus collectors and lately also through OTel, OpenTelemetry support. Migrations between the workload between the nodes for the workloads are supported. Doing live migration, it acts exactly as vMotion. You can have also dedicated networks for that, so you don't interrupt your production traffic with it. And vSwitch concept, which is used on vSphere to bridge your physical network to the virtual, so that it can be consumed by VMs. Here is replaced by Multus. Multus allows you to attach multiple network interfaces to a VM. So you're not forced to just, when you migrate your VM to OpenShift virtualization, to just use the internal overlay. You can still expose that particular VM externally on dedicated let's say VLAN or a layer 2 network that you want to connect to. This is useful, of course, for migrations as a intermediate solution before it's migrated to the ingress controller and access moved across, or for workloads that have a requirement to actually be present directly on the network. Okay, so all those storages that you have here, this is a list generated from Red Hat support page. If you see any of those on that list and you identify something that you already use, you can be sure that it has a support for OpenShift virtualization that allows you to run all the workloads in the way that and use all the capabilities for them. So live migration, snapshotting, backup, disaster recovery, and so on. If you just have a plain old iSCSI or maybe even an NFS server, which is not really recommended for many reasons, but if you have like an iSCSI or a fiber channel, you can also easily connect that to OpenShift virtualization. There may be some additional planning and architectural considerations required, but it's all doable and possible. Okay, so now I sold you on OpenShift virtualization. Now you're asking how you can move across from vSphere or from Hyper-V or OpenStack or maybe you already use Red Hat virtualization, which I would like to note here, it has been deprecated in favor of OpenShift virtualization. So the next step for if you use that would be to migrate to OpenShift virtualization. I will show you later in the demo a migration process from vSphere to OpenShift. So below, this is leveraging open source project called Forklift. It can do cold migration or warm migration. So cold migration means the VM on source side is shut down, the data is copied across, and it started again on the target, so on the OpenShift virtualization. Warm migration works similarly. It copies the storage live, and then just before finishing, it shuts down the VM, finishes the synchronization of the state, and starts that VM on the OpenShift. What it also does, you're also required to define mappings because the data needs to be moved from one storage to another. You may have multiple types of storage that you expose on OpenShift. For example, something with multiple replication options or higher performance tiers, things like that. You can provide mapping to say, okay, I want disk A, B, or C to be mapped to tiers 1, 2, or 3 on your OpenShift side. Same goes for the network. You can, by default, you map the default network to overlay network, but if you have additional network interfaces, those definitions can also be provided here. What it also happens is, as part of migration, the VM has the guest tooling from the source. So if you have VMware guest tools running on that particular VM installed, they get removed and replaced by Virt.io, which is virtualization, KVM virtualization guest tools. This only happens on the target. So your source VM remains intact. At the end of the migration, it will only be shut down. So if you're not happy with how VM was migrated, or you identify there are some issues that would need to be addressed, you can just delete the target VM, restart the source VM, and that is your rollback. It has no effect on your source. Now, the demo I will show you later is just migration of one VM. If you are in a situation where you have hundreds of VMs, perhaps thousands, it makes sense to leverage Ansible automation platform, which provides you with playbooks and methods to migrate VMs in a strategic and methodological way to across to the OpenShift virtualization. Okay, now that we have that also covered, again, any questions? No. So how would you approach that migration? It would be quite a typical process. First, the requirements would be gathered, your goals, your current environment would be assessed for workloads, what kind of skills you currently have, what are the specifics of your workloads that would need to be addressed, and also to understand how to integrate OpenShift environment with your existing infrastructure, such as networking and storage. What kind of backup, disaster recovery, and monitoring tools you use, and how to in the best way integrate that with OpenShift. There are many ways for that, and that would be a specific part of a workshop that would be organized for that purpose. After all those artifacts are identified, a solution would be designed that would provide amount of required work, timeframes, and provide initial input for pilot solution. So after that, there is the decision to be made to go ahead or not, and if answer is positive, then the roadmap and the pricing can be established, and project can be kicked off. Okay, so now this is part where we get to the demo of the OpenShift virtualization. For that purpose, I have provisioned a demo environment. This is live, so it may not be the quickest in a way that you could cut out some parts for if you would have a recording, but it will also give you a good view of how that looks like and how it behaves. So you would get another tab here for virtualization. And let's do, for starts, let's provision a VM. Maybe that will be something that is typical and easy task to do. Okay, so if you want to do that, we go to virtual machines. Let's create a new project for that purpose. That's VM. Okay, and now we want to create a virtual machine. So we click here and we say from instance type or from template catalog, maybe better. And we want to create, let's say, spool Fedora VM. There are some customizations that you use, but let's just, for the purpose of this demo, let's accept them. You can define how much CPU and memory that's going to be used, how it's going to be connected, any additional hard drives, and that's it. You can also use cloud config for injecting, let's say, some initial configuration artifacts, or in case of Windows, you can also use unattended installation scripts for at this point. So to provision a VM, this is backed by a template which uses an image that is stored as a PV, persistent volume. It clones that image, so you can also create your own templates that are already prepared with your environment in mind. For example, have certificates injected or configuration options defined that are specific to your environment. And that's pretty much it. So you have, of course, web console. This view is probably very familiar from any kind of hypervisor solution for everyone. So maybe that, okay, so I'm going to show anything for us now. It takes a little time. What you will also notice, all the virtual machines that you create are represented as virtual machine instance. This is a resource that actually corresponds to, well, to the running instance of the virtual machine. Definition itself is stored in virtual machine resource that owns virtual machine instance. And that virtual machine itself is owned by a pod. So pod is actually the resource that is being scheduled on the node. And wherever that pod is scheduled on which worker node, this is the node that it will also be running the virtual machine itself. Okay, maybe it doesn't like Firefox or something. You can also live add disks or remove them depending on guest support. Same goes for the network interfaces. We don't have enough time to go through adding, let's say, bridge network to external interface, but you can do that. You can decide on the eviction strategy of each node, which can be live migrate or restart. So what this means, let's say your hypervisor node needs to be put in the maintenance mode. You want to evict all the virtual machines to different hypervisor nodes. You can configure them to either live migrate or stop and start on another node. Let's try refreshing. Ah, here we go. So yeah, pretty much you can copy. It's not going to work. I have to type it in, but yeah. You also have all the metrics available here. Of course, you can also do the all provisioning, meaning that you can have more CPU requests and memory requests that actual hardware provides. This also means that in case of, let's say, memory or CPU pressure, you can expect evictions of the VMs to different nodes. That can all be controlled in a very fine-grained way, depending on your requirements. So you can over provision, and you can say the VMs that are maybe highly available by in their nature or stateless are evicted first before the other VMs that would cause downtime or interruption in your service. Okay, so that's that. what we can do now, I can also show you a quick live migration of that virtual machine. So like I said, this is a typical OpenShift or Kubernetes resource. So if I click here on YAML, this is your definition of that VM. It means you can also apply this resource here as through your GitOps process, and it will create a virtual machine. So that this is how the concepts that you already used from the Kubernetes or OpenShift world are applied on the VM management. Okay, so let's check where that VM is running. Like I said, where the pod is running, this is where the VM is running. So it's running on the node TF3 at the end. Okay, so this is the virtual machine instance. And if we go back to where we were before, owner virtual machine, we can just say migration and compute. You can also migrate storage, but again, that highly depends on your underlying storage. Okay, and I see that there's a different node here, HDF1 at the end. And now this was live migration, so the VM continues to run. If I would check the uptime, I would see that it's same as at the first start. Okay, so this is very typical. And what I showed you here is something that you are already familiar with from other hypervisor platforms. Let's try to do migration from vSphere to OpenShift Virtualization. For that purpose, there is a separate vSphere environment provisioned that contains some VMs. They are all powered off at the moment. And like as I said, you have hard disk here, and you have a network adapter, which is very typical. And those two resources needs to be mapped in the OpenShift virtualization. So now let's go to virtualization view, migrations. We don't have any migrations, so we have to first go to okay, administrator migration providers. So first we need to connect OpenShift virtualization with vSphere. Those are all the different providers that can be used. So we can migrate from other OpenShift virtualization deployment, OpenStack, legacy Red Hat virtualization, or you can just import a OVA image, which is used by Hyper-V, for example. So, okay, Sphere, whatever. And this is a vCenter API that we need to provide. Okay, let me find what is the URL. You can just use that, right? Okay. credentials from here. Find them. Okay, so what happens now? This provider is connects to the vSphere and lists all the VMs there. So I should be able to see all the VMs there, and I do. Database, HA proxy, and some additional ones, but yeah, I just don't have the view for it. Now, what we need to do is create a migration plan. No plans found in namespace. Okay, it detects VMs, networks, and hosts. Here, and say create plan. VMware, so that's the one that we have just created. We say which VM we want to migrate. Let's say we want to migrate this one and this one. Host, so local, which namespace. Again, here is the mapping. This one, map to pod network. And this storage map to this one. Create migration plan. That's some verification. Should become ready any moment. Here we go. Now, the only thing that's left to do is click Start Migration. And if everything ends successfully, then we should see 2 new virtual machines running here in that project. And that would be it. So you can see that it's actually doing them in parallel. And you can also have a look for troubleshooting purposes if there are any issues in the logs. And you can also monitor the process here, what's the current status of it. Of course, if you have any specific requirements or questions, feel free to either ask now or reach out after. We're more than happy to assist you in your journey. So I should already see, for example, volumes that have been mapped. So 21 and 5 gigabytes, and probably, so this one is 21, and that one is 5 gigabytes. Again, this plan is just a plain old YAML file, giving you options to automate that process and pipeline in any way that is compatible with your environment. It also gives you a current state of the disk transfer. So this one should finish soon. There we go. Let's copy it across. That means I should be able to see a virtual machine here. There we go. Let's start it and see what happens. Maybe something that is interesting for some newer use cases is the process of migration. The most of the time would be spent in actually copying the data across. There are efforts that are being implemented. I think Hitachi has the first kind of solution for that, where the copying between the between the, let's say, vSphere hypervisor and OpenShift virtualization is not happening through the, let's say, through the network where the data is copied block by block, but it's actually implemented on the backend in the storage itself. So this would allow you to migrate workloads much quicker. Okay. Do we also have, not yet, the Windows machine yet? Nope. Okay, 5 more gigabytes, but it may take some time. It may be over. Okay, that has also been migrated, so let's start that one up too. All of this clicking is, of course, has equivalent CLI commands too. And so I'll keep this running, but otherwise, this concludes the presentation. And Max, word back to you.
Yes, if there are any questions, please raise your hand or add it in the Q&A screen.
We also have Yanis here. He's a sales expert from Red Hat side, and he's also more than happy to answer any of your questions from that topic.
All right, if there is no questions, feel free to contact us afterwards if something still comes up. Otherwise, we can end the session. Or Alice, do you still want to continue something?
That's it from my side. Yeah, so I'm glad that I was able to do the demonstration for you, and hopefully this is something that will give you some more information to continue in your story.
Thank you very much, Alice, and thank you very much for everyone that participated.